A lot of people ask me about conscious computers. Can a computer ever be conscious? Will we ever live to see a computer that's conscious? So I'd like to address that subject. And as I address that subject, we will talk about consciousness in VR. How does consciousness play inside of VR? Okay, so some of this will be things I said before, and some of it will be new, or at least new perspective. So first, let's talk about the conscious computer. In order to have consciousness, one has to have awareness and a choice, because that is MBT's definition of consciousness. It's awareness with a choice. So if you have awareness and if you have a choice, and of course, if you have a choice, then you have free will. Because if there is no free will, then there is no choice. This is not consciousness with an illusionary choice. This is consciousness with a real choice. So consciousness and free will. So how will a computer ever get free will? So that'd be the first question to ask. Right now, if you look at that small minority of physicists and other, I guess maybe even biologists or other just kind of technical people, you'll find that there is a minority that think that if a computer were complex enough, if it had enough complexity, then free will and thus consciousness could evolve from that complexity. Well, that's close, but not quite right. Complexity is not the fundamental requirement, okay? You can have a system that is very, very complex and still doesn't offer any free will. So complexity is not enough, though complexity is a component, but we have to look for something more fundamental than complexity, and that is uncertainty. If you have a computer where the choices being made are uncertain, and what I mean by that is nobody would be able to determine just what that choice is going to be. It would be a choice, but everybody would just have to wait for the choice to be made, and nobody could guarantee that the choice would be this way rather than that way. That's what I mean by uncertainty as to the choice. So if the choice contains uncertainty, it can't be specified ahead of time, okay, then that is a real choice. Okay, that says that there's a decision space that an entity, we'll just say entity to now for just some generalized awareness, that an entity will be able to make a choice. And that choice is not part of an equation. It's not part of an algorithm. It's not, if the sky is blue, then the trees are green, because then, if you ever see a blue sky, then the trees will have to be green. That's an if-then statement. And in a computer, that is deterministic. The blue sky determines the green trees. Okay, so this has to be non-deterministic. Another way of saying that is that it's non-computable. There is no deterministic chain that takes you to the answer. The answer comes from someplace else, and that someplace else is uncertain. Now, it's not just an answer that comes from a random number generator. It's not like we have a list of numbers and the random number generator will just pick one of those answers. You ask it any question and it'll pick an answer and tell you that. So you may say, how tall are you? And it may say the trees are green because that's an answer it has. But of course, that's nonsense. That isn't awareness making a choice. There's no awareness involved there. That's just randomly picking a choice. So that's another thing. The choice can't be just a random choice. It can't get its uncertainty from a random number generator. The uncertainty has to come from the process of making the choice. Okay, that's, so that's the key idea. Now, if you have a system that is very complex, but that complexity is such that nobody really can trace what's going on because it's so complex and so many things affect so many other things, or so many variables that you just don't know how it got to that answer. Well, that's what the scientists are thinking of. They're thinking of, it's so complex that nobody can really tell what answer it's going to come to, given a question, what meaningful answer. But as you see, complexity is not enough. It's really not about the complexity. It's just about the uncertainty. Now, you don't need a huge amount of complexity in order to create uncertainty. You can create uncertainty rather simply. It doesn't need a lot of complexity. For instance, we have a neural network. A neural network is a computable thing. It's code that you can write, but it creates a system that learns, and as it learns, it creates its own, it modifies its own software as it learns. So it's a system that takes in input like we take in experience. And we could say it's a system that has experience. And in that experience, it modifies its internal coefficients, its internal, coding, if you will, the things that make it work. It changes those things. So in order to make more sense out of its experience, in order to, meet a certain goal. Like you could have one of these systems play chess, or you could have one of these systems look at pictures and tell different species of dogs, or human males from human females, things like that. And you teach it by giving them lots of pictures, say, of the human males and human females, we take that example, and we tell it. We say, this is a human female, this is a human male, this is human female. And after you've given it thousands of pictures, it has adjusted its own parameters so that it understands the differences between those two in these pictures. And now you just give it a picture and say, what gender is this, male or female? And it will tell you. And it can be very accurate. It depends on how complex, how intricate or how well made the neural network is. There's simple neural networks, there's more complex neural networks. And also it depends on the training. If you only gave it 10 pictures and then asked it to tell you what sex it was, it probably wouldn't do very well. It maybe only get 60% right. But if you show it tens of thousands of pictures or hundreds of thousands of pictures, it's going to get 99.999% of them right. Matter of fact, there is a neural network that plays chess now that I just was reading about a few weeks ago, and it can beat the brute force chess masters like Deep Blue. Deep Blue is an IBM computer, and that computer has in it programmed every chess match that's ever been written down. Every match, hundreds of thousands, if not more, of chess matches. It has all the possibilities of all the moves, and it will work out what are the possible moves. Then, let's say one move, then what happens next and what happens next, and it can work out for the next 10 or 20 moves what would happen, and then it comes down and works out the next possibility. That's just brute force. In other words, it just goes through all the information from all the chess games that have ever been recorded, and all the clever people who put in their general rules about playing chess, things to do, things not to do. So it gets all that information in there, and then it just starts to optimize across all that information. Well, let's try this. Well, no, that doesn't work very well. That's against this rule or that, whatever. And that's brute force. And Deep Blue beat Gary Kasparov for the first time, a couple of decades ago. And computer actually, beat a chess champion, kind of the world's best chess player. Well, that was decades ago. But now there's a neural net that basically just, you give it information. You just start with nothing. Give it the rules of the game. Here's how a bishop can move, here's how pawns can move, and so on. Here's how knights can move. You define the game and the rules and just say, go play. And you tell it what the object is, what the object of the game is. And of course, the first couple times it plays like a 3-year-old, that just barely knows the rules. But it wins or loses or does what it does, and it goes on, and you just let it play and continue to play and continue to play. And they put these on some very fast computers. So in 6 or 7 hours, they can play like 3 million games, because computers are fast. So they can play games in, milliseconds. So in any case, this neural network, just by giving it the rules of chess and letting it play games, now it beats Deep Blue. The brute force computers are not as good as it is. You see, it's changed all its own internal coefficients and numbers and things. It's reprogramming itself as it learns. Now, in this particular thing, they trained it. They gave it, I think, something like 7 hours to train. And after 7 hours of training, it was able to beat basically everyone and everything in 7 hours of training. But that 7 hours was, probably hundreds of thousands, of games, maybe millions, I don't know, but it goes through them very, very quickly. But that's about all the time it took for it to become, the best chess player ever. So that's a neural network for you. Now, the thing that was interesting about that is it did not start with any of the classical moves, or it doesn't always. Sometimes it just starts with stuff, right off the wall. And Kasparov actually was writing in this article, a little article about it, says this thing doesn't play like a machine, checking all the possibilities and then making its best move. It says this thing plays like a human. This thing does stuff that is sometimes, why did he do that? Where's that going? But he ends up winning most all the time. So that's just the example of a neural network, of the kind of power that's in neural networks. So nobody programmed in all the winning games or all the rules of making best moves. It figured out all out itself just by randomly playing the game until it knew, well, I did this and that won, so I'll do more of this. Oh, I did that and it lost, so I won't do that anymore. And it just plays hundreds of thousands of games until it figures out for itself the best way to play chess. You see, neural network. Okay. And in Kasparov's words, it plays like a person. It doesn't play like a brute force machine that just, evaluates everything and then makes what it sees as the best move. Evaluate everything and make the best move. Now, the reason Deep Blue won is because if you have all of that information at your fingertips, that makes you hard to beat. Every game that's ever been played, it's ever been recorded, it's all programmed in there. I mean, how many different ways are there? So there's lots of things that machine has. And the average person can't play that way. The average person doesn't have that much information. And if they did, they couldn't process it that quickly, but computers can. So just by brute force, Deep Blue and other machines were able to be very excellent chess players. But this little neural network is not like that. And it doesn't take a giant supercomputer to back it up with lots and lots of data. It's just a neural network. So Anyway, that's just a little background on neural networks so you get some idea of what they do and how they have evolved. This latest one, I wish I could remember the name of it, that is so good at playing chess. Oh, I remember now. That neural network we're talking about, that was produced by Google, and its name is AlphaZero. I mean, it's very contemporary in the sense that's something that's evolved in the last few years. You know, that the neural networks have gotten good enough. And the people who make these are computer scientists who are studying intelligence and computers, and they make these things just to see how they work and how well they do. Okay, so nobody knows exactly how this chess playing neural network works and why it makes the moves it makes. Now, you could trace every move that it made and say, oh, it changed this coefficient and it changed that. And you could track all of that. And that would be fairly complex, but you could track all that. And then you could say, oh, that's why it came up to that choice, because of these things being balanced and this new input, then I can see that it would make that choice. Okay, so you could. So that's not really saying that it is beyond calculation, but it doesn't have to be beyond calculation. What it has to have is uncertainty, because nobody tracks all those detailed changes that the neural network makes on itself. You know, it changes its own software. Nobody tracks that. It just does it. And nobody knows exactly what it's changing or why it's changing it. So there is uncertainty as to what it's going to come up with next, what its next move is going to be. There's no way that anybody could deduce what the next move has to be, because all those changes that it made were made on its own and nobody really tracks them. Okay, so that's uncertainty. So now you have a thing in a computer, a system, a piece of software that has uncertainty in its choice. See, that's free will. So it's making choices by free will. Now, like I say, you could have little sensors in there and little things that would keep track of all of the little things going on inside of that. And then you probably could predict what its next move would be. You might be able to if you had all that. I'm not even sure that that's possible, but we'll just assume that you could do that. But the point is, if you don't do that, you have free will. You see? So having a computer with free will is not all that hard. We already know how to do that. Now, the complexity doesn't have to be huge. It's just a neural net. We know about neural nets. Anybody can sit down and compute, make a neural net on their computer. It's a simple neural net. You could probably do it in a half an hour. It's just not that hard. It's not a hugely complex thing. But it changes itself. Once you start training it, it changes itself. And after that, you don't know why it makes the choices it does, because it's got maybe 10 or 20 or 100 parameters, and it just changes them based on training. Now, there's two kinds of training. You can give this computer, say, 10,000 pictures of males and females and tell it which is which in the beginning to train it. Or you can just let it interact with people and let it guess. And then you could tell it, whether it was right or wrong. You don't have to show it pictures. Or you could give it some sort of a process where it could maybe not know for sure it was right or wrong, but whether or not it thinks it was right or wrong, whether or not it was getting close to being right. Give it some, like maybe there's 10 criteria or 20 criteria. And maybe if it gets 14 out of the 20, then you'd say, okay, consider yourself being right. Maybe that's a male or that's a female. Like how far distance between the eyes, face shapes, all sorts of things that it might go on. So you can learn as you go. not as efficient as just being taught, but you can learn as you go. Depends on the kind of problem you're working on. So you could set this thing up, say, with a camera at the entrance to the men's room. Everybody that walks in to the men's room, this camera gets the picture of their face as they walk into the men's room. And then it just says, okay, anybody walks in the men's room, that's male. Now, it may not always be right, because female may walk in there too sometimes, or janitors come and go in there. Sometimes there could be either sex. So it's not going to be right all the time. So that would be an example of just learning from real life. So you're not going to get, it's not as efficient as just being trained, but you can set up something and let that camera be there and let that neural net work there. And after it's been there for a couple of months, well, okay, it had a couple of wrong answers. There were females that went in that room to clean it or to do whatever, to check maybe guards at night, to make sure there wasn't anybody in there, as the building's being closed. Who knows? But you let it run long enough and it would get very good at what it does just by experiencing life under that situation. Okay. So what happens with this computer that has free will in this neural net is that if this computer did things, was in charge of things, had the ability to make choices that were moral choices, ethical choices, choices that mattered, choices with consequences, okay, then the larger consciousness system could take a piece of itself to go make those choices. You see, and now you'd have a conscious computer. Not because you have somehow cleverly programmed consciousness, but you've created a platform, a system that consciousness can then make those choices with an IUOC. So the system would spin off an IUOC. That IUOC would log on to that avatar. Computer now would be an avatar, just like a human is an avatar. And it would then make those choices. But conscious system isn't going to create an IUOC to identify males from females. You see, there's just no challenge in that. There's no growth. That's not something that a consciousness is going to evolve because it differentiates between males and females. So as long as it has tasks like that, then no consciousness is going to want to play it. So you'd have to give it some sort of responsibility. And the system could choose to have an IUOC make those choices. Now, the system may choose not to. The system isn't forced to do that. It's just that would be available to the system to have a consciousness do that. Now, would that consciousness be like a human consciousness? No, it's not going to be like a human consciousness. Okay, there are differences. Human consciousness is the way it is because humans are the way they are, I guess that doesn't explain a whole lot, but computers are conscious is going to be like computer consciousness because the way computers are. They're going to be two different kinds of things. And you know how we say that the avatar, be it computer or be it human, that the avatar sets constraints on what the conscious can do with that avatar. So though I would like to flap my hands real fast, and I'd be clever, I'd flap them down like this, and then I'd turn them sideways to go back up, and then flat to go down, and sideways to go back up. So now I'm actually pushing air down, not pushing air down, pushing air down. And if I could push enough air down fast enough, I could fly. Well, I can't. It's not just me. No human's going to do that because we weigh too much and our palms are too small and our joints aren't made to move that fast. I'm sure some engineer, physicist could do the math and tell you that in order to fly like that, you'd need to move your arms something like, 10,000 times a second or something. You'd need a whole lot of this real, real fast. You'd be like a hummingbird. See, hummingbirds do that. It's exactly what hummingbirds do. Okay, we could fly like hummingbirds if we could move our arms fast enough, but we can't because we're pretty heavy, and it would take an awful lot of up and downs with our little palms, to get enough force to lift our heavy weight. So anyway, consciousness just can't do whatever it wants with the avatar. It has to abide by the rule set. The rule set for me, for the human avatar, has to do with human evolution. My joints and muscles only move so fast. I can only move my arm up and down so quickly. My shoulder joints are made such that there's limits to that. A hummingbird can move those wings a whole lot faster than I can move my arms because their joints are made differently. Their joints are made to do that sort of thing. So you see how the avatar evolves and what the avatar's made up and how the avatar's joints work and all sorts of things determine what the consciousness can do with that avatar. Well, a computer isn't a human being, so you're not, it's going to be different. What the consciousness can do with it's a different sort of thing. You're going to have a different kind of consciousness. That's going to want to work, that different sort of avatar. So let's work at this consciousness thing, consciousness in a VR. Let's work at that from both ends. First, let's work at it from the evolutionary end. Okay, we said that this virtual reality is an evolved virtual reality. The larger conscious system didn't program it. It set up initial conditions and a rule set, the rule set being basically physics, a complete set of the rules of physics. Then when it punched the run button, that ball of plasma, that was the initial conditions, high temperature, high pressure, is allowed to move according to the rule set. It's allowed to change. I shouldn't say move, that's just one change. It's allowed to change according to the rule set. Well, it does. And that plasma under the high pressure, it expands. As it expands, it cools. As it cools, things coalesce. As we have gravity is one of the rule sets. And you end up with suns and planets and a universe like ours. Okay, that's the big digital bang. All happened, it all evolved in a computer. Okay, so eventually that big digital bang produced a planet like Earth going around a sun like ours, and cells started to occur. So we have cells, single-celled things like bacteria, and that's kind of all the life we had was bacteria-like things, kind of protozoa-like things. And eventually those things became multi-celled things. One of those bacteria split, and became a two-celled thing, and then split again and became a four-celled thing, and so on. So all of those things, those changes that take place like that, you have mutations, things change. In other words, things just try different things. So this is a virtual reality. How does that mutation process work? Well, from an evolving things, there's multiple ways that a thing might change, multiple ways that it might go, multiple ways that things could go together or come apart. And all of these things are generally tried. It's the concept of emergent complexity. That is, if you have possibilities, eventually stuff happens. All those possibilities get triggered eventually. It takes a long time. Evolution is slow. It takes a long time, but eventually things happen. Mutations happen. All right, now in a virtual reality that's evolving, there's lots of ways that it might evolve. There's lots of ways things might happen. So the system probably just picks some of those. Okay, here's something. Now, what are all the possibilities where this could go? What are all the kind of things this could do? Maybe there's 100 different things it could do. And some of them are really strange, like cell division and multiplying and having two cells. Maybe that's one of them. And maybe that's only 1 in 100 million. But, 100 million times come and go, then, oh, there it is. You got that mutation. You got cell division, you see? So it works that way. There's lots of ways that things could change. There's lots of possibilities. How does a simulation pick which possibilities it's going to use? Well, it does a random draw from a probability distribution of the possibilities. And sometimes those mutations are really off the wall, really unusual. Sometimes they're typical. Sometimes there's, the change is that it gets hairs that wiggle like this. And maybe the next change is it gets hairs that wiggle like that, What are they called? Cilia, little hairs on the side of a cell. So a lot of the changes are going to be mundane, but sometimes really odd things will happen and you'll get something new popping up. Okay. So that's the way the evolution works. So almost all the possibilities are tried, and those that produce lower entropy, those that produce something more survivable and better able to procreate, they continue, they move forward, they stay, they multiply. The things that don't work very well, like a human that has to fly, but can't move his arms fast enough, well, those never do materialize. They never happen. And the things that do happen, but are counterproductive, makes you less survivable and less likely to procreate, then those things go away too. They become extinct. So that's how the evolution works. It just mutates into the possibilities. Eventually, those mutations hit on things that are important to survival and procreation, and bingo, we have a winner. And that winner goes forward. Every time you have a change, you scramble the possibilities. The probabilities and possibilities all rearrange themselves because now you have something that's different. So that's how the evolution works. It works basically from the bottom, things that are very, very simple, and creates over time things that are very complex. Okay, that's the nature of evolution in a digital system, in a VR. Okay, so that's an easy thing to program. You just look at the possibilities, you pick those based upon probability, and eventually you sample almost everything that's possible, and what works goes forward, what doesn't work ends. So we end up, a couple of million years later with Earth, with humans, and humans building computers. That's what we end up with if you let that evolution go long enough, and humans building computers that produce virtual realities. So we end up with all of that. Now let's look at how consciousness plays into this. And this is kind of the where the rubber meets the road between the materialists who would like the body to create consciousness, and then the idealists who think that there is a realm that is fundamentally non-physical that is the source of things. That's kind of the idealism. And the realism is the materialist viewpoint, is that everything is generated out of the physical reality, or in this case, out of the virtual reality. Okay, so we have this evolution going on. So, okay, things evolve, and they evolve a control center called a brain so that the body can move and be coordinated. It needs a brain. Simple things didn't have brains because they didn't really have things that had to coordinate so much. They weren't that complicated yet. A jellyfish doesn't have to have a brain. It just does what it does. It's all kind of driven by instinct. It doesn't have a lot of coordination to do. It just goes wherever the tide takes it. But then we go to things like a fish, which does have a brain because it's got things it needs to coordinate, body motions, muscles, and so on. Things have to work together. It's got internal organs that have to function along with other organs, and they all have to take their place and be balanced and just do the right things at the right times. They're more complex, lower entropy. Okay, so that continues to grow. And as the requirements, as the decision space, as the possibilities of the organism get more complicated, okay, then the brain gets a little bigger because it requires more coordination, more instruction. Well, that goes to the point that kind of defines, let's say, the human, as far as the human's body and how that body has to be coordinated, how that body needs to be able to run and jump at the right time, not the wrong time. It needs to, be able to, be conditioned so it can run maybe long times, or maybe it needs strength, and it evolves to do what it needs to get by and survive, just like all the rest of the animals need that. Okay, so they all evolve their physical system to deal with the environment in which they are evolving in, this digital environment, the bushes and the trees and the rocks and the other animals and sources of food and predators that might be, wanting to eat them for lunch. So all these things are part of the environment, and the system keeps evolving. So we have this brain then that's being evolved up, from the bottom up physically, in order to master the body and that body's instincts, which is like the things the body learns to do in order to survive. These things are kind of hard-coded in the body, in the genes, certain survival issues, the fight or flight being one. It's just encoded. So we have that going on. And as the human develops into doing more things that need more cooperation, then the brain develops to do more sophisticated things. And so on, we realize, we look at a human brain and it's like an overlay of like 5 different kinds of brains, so we developed up this far, and we have what they call reptilian brain, and then and so on. And so it's a patchwork of all these things, one built on top of the other, to kind of represent where we are. So that's the bottom up in evolution with biology. Okay. It's just chance things happen. We call those mutations, and they either are profitable or not profitable in that environment. So they continue or they don't. So that's the human, and the human has this brain so that it can get by in his environment. Now, let's do the top down. That's the bottom up through evolution. Now let's do the top down. All right, we have these human beings and their avatars. They're being computed by a computer. So all that's being computed is just what you see. Only thing being computed are the things that other players' 5 senses can sense. So we know that human smells, it's got BO, it tastes, it hears, it sees, it feels. So it has those senses. Okay, now the human then is you say rendered by the virtual rendering engine for the virtual reality. It's rendered just in as much as some other human sensors would be aware of it. So things like a brain are never rendered. Things like a heart and a liver and kidneys are never rendered because somebody else's sense data don't pick those up. So why would the computer render things if didn't make any difference to any of the interactions of the players? So they wouldn't, until one day some player cuts somebody open. Oh, well, there's something in there. The system has to render something in there. Otherwise, it would have to render nothing, just black, nothing. You'd unzip the body and nothing would be in there. It'd be a void. Well, that doesn't work in a virtual reality. You can't just have voids, floating around. So whenever you dig into something, whenever you look inside, the system has to render something. So what does it render? Well, it does the same thing from the top down as the evolution does from the bottom up. It says, Well, what are the possibilities of something that would be in there? All right, there's a whole bunch of things could be in there. And here's the probability of those things being in there. And now I'm going to take a random draw from those possibilities, and that's what's in there. All right. So it does the same thing. Whenever it has an unknown, it takes a random draw from a probability distribution of the possibilities, and that's what's in there. But now it can't just put anything in there. It has to have the things that are possible and the things that are probable. So how does it know what's possible and probable? Well, it's got evolution. This thing has been evolving. So it knows if you tear open a head, there's going to be a brain inside, because that's the way the evolution has worked to make this avatar more survivable, so that it could coordinate its arms and its legs, so that it could climb trees or do whatever else it needed to do. So it could maybe build things with its hands, make a spear, make a bow and arrow. It could do some things. All right. So you see, from the top down, when it says, what are the possibilities, it's going to look at its own evolution, because it's the same system is evolving from the bottom up. And it's going to say, well, okay, there's going to be a brain in there. That's a probability of 1. It's not going to be a cucumber in there, or, you know, a rubber sponge ball or something. There's going to be a brainy kind of thing in there, because evolution tells me that that's a probability of 1. So we know we're open ahead. We're not going to find a lemon. We're going to find a brain. So it chooses a brain. Now you cut that brain open and, oh, let's look inside. Oh, look, here's a neuron. So we say, look, there's a bunch of things. We'll call those neurons, and they're zipping around. They're connected. They got synapses between them, and we see all this stuff. And that's sort of the way brains work. So it renders that. And then we go inside of that neuron. Somebody takes a neuron, pulls it apart, looks inside, and say, oh, what's inside this neuron? Oh, look, they're really tiny tubes in there. They look like nanotubes, nanotubules. Well, how about that? Maybe they're just structures to hold that thing together, sort of like the bones, the skeleton is a structure that holds the body together. Maybe those nanotubules are just construction members, hold things together. Maybe not. Maybe they have a function. Well, the bones do. The bones have marrow that make red blood cells. They're not just bones. They do other things. So who knows? They find microtubules inside, or nanotubules inside that thing. Well, okay. Now, if you take one of those nanotubes and tear it apart, you're going to find something else inside it. And if you tear that apart, you're going to find something else inside it, until you get down to the lowest, simplest, elemental piece of biology, a cell of some sort, or a part of a cell, or a substance of some sort that the biology creates. Okay, so you're going to be able to tear things apart eventually until you get down to atoms. You get down to molecules, then you get down to atoms. You can tear the atoms apart, and then you get elementary particles like electrons and neutrons, and then you tear the neutron apart, and you're going to get things like quarks, you see. And that just keeps on going, because in a virtual reality, every time you tear something apart, the system has to render something else there. It can't render nothingness, and it has to be something that is possible by the rule set. And it's a random draw from the probability distribution of the possibilities. Sometimes that possibility is 1, so it just gets that, because it has to be that. It has all the facts of evolution to help it decide what's in there and what the function of it is. So those two things meet in the middle someplace. Now, some people believe that these microtubules are the creators of consciousness. Okay, that's the thing that creates consciousness. Other people believe, and that's probably a smaller minority, probably a handful of people. Then there's 2 hands full of people, but still a pretty small minority that think it's the neurons, that those neurons and their interactions and the numbers of them and how they interact and how they communicate with each other and so on, that is, they say, complex enough. But again, complexity isn't really the issue. It's whether or not it creates enough uncertainty as to be able to create free will. Okay, does it create enough uncertainty? Well, it doesn't take a lot of uncertainty. Like I say, just a simple neural network can create enough uncertainty, and you can make one of those in a half an hour on your computer. You don't need a lot of that. So these are things that materialists have been talking about when they try to find a physical source of consciousness. They say, oh, you know, it's the neurons. There are complex interrelations among neurons that are so complex that nobody knows what's going on there. Therefore, there's uncertainty as to what's going on. Therefore, you could have free will. Therefore, if you have choices and free will, bingo, you've got consciousness. If you have awareness and free will, you've got consciousness. Okay. And others thinking, well, the neurons aren't it. Because, well, I don't know that they really say because. They just think that the microtubules is going to be it. And I think the reason microtubules get picked as a potential source of consciousness is because they're small enough to be down into the quantum realm, because they're nano things. Anything you get really small, then you get down into the quantum realm. And because quantum mechanics is known to be non-local, non-computable. It's known to do things that are just weird. So they call it weird physics. Well, consciousness, we know, is also weird. It does things with no explanation too, like remote view. You know, it can do things like that, like have intuition. So we know that quantum mechanics is well, science calls that non-local. You know, we can just call it weird if you like, but you know, so quantum mechanics is weird and non-local and non-computable. And in that case, then surely those microtubules that are down in the quantum realm because of their size must be the source of consciousness. So I think that was kind of the key that triggered that investigation. But like I say, that's a smaller minority. The bigger minority say, well, you don't need all that. And besides, quantum things are not stable in that warm, wet mass called biology. You know, for quantum events to be stable enough to do anything, you need to have really low temperatures so everything's not banging around into everything else. So they think it's at the neurons. But the point is, we have the top down now, you know, you take things apart. So we're looking at the physical anatomy of the avatars, if you will, and we're looking at the avatars having evolved from the ground up. And these avatars, let's say the humans, they're conscious. They are conscious. We know that. Now, then the big question is, are they conscious because consciousness is fundamental and they are a piece of consciousness playing an avatar? Or is there no such thing as conscious being fundamental and consciousness is created by neurons or nanotubes or some other kind of thing? Okay, well, where you would go to kind of decide which way that is look at the system. What is this system? The system that's creating the virtual reality. And we look at why is it doing that? Well, in my model, of course, we have consciousness is the system, okay? And consciousness creates the virtual reality, so IUOC's individual units of consciousness will have some better choices and can evolve the quality of its consciousness more readily. So consciousness of the players and the avatars are just empty shells, if you will, just what you sense, nothing more. The only reason you see a brain is because the system has to put something there, and evolution kind of informs it what would be a good thing to put there. Okay, so we have that. So if you start with the consciousness system, that becomes obvious. And if you start with that consciousness system, you can explain a lot of other things too. You can explain why speed of light is a constant. You can explain why quantum physics is weird. You can explain that weirdness away and quantum physics becomes rational. You can understand why the double slit works the way it does. You can understand why all those various quantum weirdness, why it is that way, and reduce those to logical processes rather than weird processes. And you can understand things like remote viewing, mental healing, communications, telepathic communications, all of things which have been around since forever and are real things. And if you don't believe these are real things and you think all of that stuff is woo-woo nonsense, then basically you're just ignorant. There's plenty of science out there. Plenty of things have been done. I mean, even look at university, programs that have been studying psi and psi events, parapsychologists. Okay, that's been around now for decades. Started back with the Rhine Institute, down in Duke University. I mean, there's tons of credible evidence that these things do exist. Anybody can learn to remote view. Now, not just anybody will get really good at it unless they practice a long time. But if all you want to do is do something amazing that's impossible, well, go take a remote viewing class. And within a month, you will probably have had a successful remote view. All right. Logically, you only need one exception to prove the possibility of its existence, right? You don't have to remote view everything and be 100%. If at one time you get a number out of a remote viewing thing, number 654321, and you say, what's the picture? I'm going to remote view it. And you say, well, it's a little train and it's moving through a field, and the field has green grass, there's purple mountains, there's clouds up here, the sun's shining over in the left, and there's a horse standing in the meadow over there. And let's see, there's a little road comes up here and a wooden fence goes along it. So you draw your picture of all of that. And then you put in your number and you look at the picture, and it's exactly that picture. Exactly that picture. Right down to the color of the horse. Had a big black splotch right there on his rear haunch, just where you put it. Well, that happens. And that is not a rare event. Even a very new kind of person at remote viewing will occasionally get something that right on. Why occasionally? Because only occasionally do they get their mind settled down. Do they get the noise reduced, in their mind, because they're probably not but so good at meditation. Only occasionally do they get their intellect to butt out and let their intuitive side get in charge. That's why it's occasional, because it takes skill to do this. But most people will stumble on it once or twice in just a few weeks of training. Actually, I train people, and I just talk about it one day, and about 30 or 40% of them will get dramatic connections. Not just sort of a connection like, well, okay, I got green grass, but that's the only thing I got. Well, that doesn't count. I mean, a really spot on from a complex picture. And if you hang out with remote viewers, even if you don't do it yourself, you will see that those kinds of things happen routinely. Well, it only takes one to prove the possibility. You see, so if it ever happens, then it can happen. And if it can happen, then it's just a matter of learning how to where you can make it happen more often and whenever you want to. That's just a matter of learning, honing the skills necessary to do it. So anyway, these things do exist. And this model of MBT, this model of consciousness, explains exactly how that works. What's the mechanism involved? People use their minds to get information, intuitive information. Just something comes to them, bolt out of the blue, and it makes a big difference, maybe in their life, or it solves a problem, or maybe it's a eureka moment, and they, they finally put all the puzzle pieces together. That happens all over. Lots of people do that. And why? What is intuition? You see, where does it come from? How does it work? And what about all the things in a person's life that are subjective? You see, the deterministic viewpoint, the materialist viewpoint, can only tell you about the objective reality, just the objective reality, nothing else. Everything else is generally considered a hallucination, an illusion. Consciousness, it's just an illusion. Time, just an illusion. Oh, intuition, that's just an illusion. Remote viewing, it's just an illusion. That's just trickery. You know, these people, they know what that picture is going to be. It's all a trick somehow. You know, it's all hocus pocus, just the work of weak minds, you know, and charlatans. Talking to dead people, well, obviously charlatans are making all that up, you see. So to the materialist, their only logical stance is to say that everything else is a hallucination. Everything else doesn't really exist. But yet there's centuries of this. There's, you know, by now, thousands of departments in universities that have measured these sorts of things. I mean, even back in Duke, they had a lot of these measurements, you know, were done and confirmed and reconfirmed and double blind and triple blind and all the rest of it. And the same with, you know, so we have all this science, all these facts, and the materialists simply find those very inconvenient. So they stick their head in the sand and say, none of that exists. All woo-woo, brush it off. I don't even have to look at it because I know it's impossible because it's not materialistic and materialism is the answer. Therefore, these things can't possibly be true. Okay, that's called a belief trap, where once you get caught in a belief, you can't see anything that is contrary to that belief. Everything contrary to the belief is automatically thrown out and not even considered. So we can, from the viewpoint that consciousness is fundamental, we can solve all those problems. We actually can turn the subjective into a science, understand why things are that way, understand who and how you are. Are you, you know, are you struggling? Are you unhappy? Do you have difficulties with relationships? Well, that science of the subjective will tell you exactly why that is. You'd like to be happy, live a life full of joy and peace? Well, that science can tell you exactly how to do that. It's the science of the subjective. It understands those subjective choices and gives them importance. You see? So another way of looking at this is that, you know, we have the objective and subjective life that we live. Some of it's in the subjective, some of it's objective. The objective part is like the props on a stage. It's all the props, you know, the colorful stuff, the chairs, the tables, all the stuff. That's the props. And the subjective stuff is like the minds of the actors, what they're saying, what they're doing, how they're feeling, the characters they're portraying. That's the subjective part of it. Now, who ever went to a play to watch the props? That's not really what's interesting. That's not that part of our life that is meaningful to us. To sit around and contemplate the props is not what we do. You know, most of our life in its richness has to do with the subjective part. It's in that subjective part that you find things like justice, right and wrong, morality, ethics, love, caring. All of those things are all in that subjective part, you see? So the richness in our life is subjective. The props are mostly objective. Props are necessary. You couldn't have a play on just a plain blank stage. It just wouldn't be very credible. It wouldn't feel right. It wouldn't get the idea across. It's not that the props are irrelevant. Props are important, but they're not the main story. Okay, so this science of the subjective is a science that is really necessary to help people understand who and why they are, why their life is the way they are, why they're making the choices they're making. They can understand that. Okay. So that tells us that if you take the approach that consciousness is fundamental, you can explain everything. You can explain quantum physics. You can explain relativity. Actually, not only explain it, you can derive it. You can show why it couldn't be any other way, why it has to be that way. And you can also derive all the paranormal things, how they work, why they sometimes work and don't sometimes work. What's the difference? You know, why are some people good at some things and not others? All of that is perfectly rational, logical, okay? Not something that's just made up. It all is logically derivable, okay? Now, so you can do better physics, and you can do better sociology and better psychology and better almost everything, and a whole lot better love and caring and you know, all the stuff that is emotional, as well as the stuff that's intellectual. All of that falls in that intuitive side. You can understand the human better. You can have a better model of what consciousness is and how it works. So it does all those improvements, and it doesn't really cost you anything. There isn't any problem that you create. You still have the physical world. It's just, actually, you know, we call that the objective world. There really is no objective world. Things that have very small uncertainty, we call them objective. But everything in the objective world has some uncertainty. If you try to measure a brick, the volume of a brick, you'd say, well, that's subjective. A brick just has a volume, and you either get it right or you get it wrong. Well, if I want that brick down to 15 decimal places, I want its volume in cubic meters or in cubic millimeters, whatever, to 15 decimal places, and you hire 10 different teams of physicists to tell you what it is, they'll all come up with different answers. It's not a done thing. It's not an absolute thing. There's uncertainty. But with that brick, not a lot of uncertainty. All right, here's the volume plus or minus, 10 cubic millimeters. All right, I measured it with a laser rangefinder and got all of its dimensions, but actually, it's not flat. It's got little lumps and bumps all over it. And you know what? Atoms or molecules are leaving all the time, and other kinds of molecules are sticking to it. And it's just really hard to tell exactly what that volume is or that weight is at any particular instant in time. It really changes. Everything's in motion, changes. So there's uncertainty with everything, but those things that have very small uncertainty, we call those objective. Those things that have large uncertainties, we call those subjective. So that's mostly the way it works, because if they're known, they're objective. And if they're known, they have small uncertainty. That's what makes them known. Okay? If they're not known, but something's there, but you don't know exactly how much or where or how it works, then that's largely going to be subjective. You think it's bigger than a bread box, smaller than a Volkswagen, you think it's this way and that, and you can but you don't know a whole lot about it, then that is it's going to be a subjective analysis because you don't know, and it's not known. So some things that are subjective, we can study them enough and they become objective because we have better microscopes and better telescopes and things. But that's, anyway. So the point is, if we go with the way of developing consciousness from the physical, then we can pretend that that will work. It doesn't really work because it's impossible to show that, actually. It's called the hard problem. The reason it's hard is because it doesn't really work that way. That's what makes it so hard. But even not starting from that, I don't want to start with the answer as an assumption. That's not good logic. But if we start from the physical side, you see, trying to get to consciousness is difficult. Now, we can get a machine to free will. Yeah. And maybe a consciousness will log on to it, and you'll have a conscious computer. But if a consciousness doesn't log on to it, then you don't have a conscious computer. You just have a computer that can come up with answers that nobody knows how it got them. That's all you've got. It's not conscious. It's just it's just a system that can tell men from women or can play chess. Okay. So it depends on whether it's interesting enough that the system would want to play it by giving it consciousness. Consciousness is not something you make. It's something that you build a platform and let it log on to it, let it assume it. Okay, so that's where MBT comes from that direction. And from that direction, you can explain everything else. You come up the other way and say that, well, consciousness is somehow generated out of a physical system, be it neurons or microtubules or whatever. Well, you still can't explain quantum physics. You still don't know why C is a constant. You can't explain anything paranormal. You can account for intuition. And yet you have this whole database full of facts, yes, very scientific facts that say these things are real, but somehow you just can't explain them that way. You see, they don't resolve themselves. So you don't really gain much. You don't really have the whole picture yet, because if you cannot also produce the science of the subjective, then you're missing probably, 75% of what's important to people. You're only having a science of the objective. So, okay, you've got those props really nailed. You're good about the props. But what about the people? What about the ideas, the concepts, the intuition, the creativity? Where does that come from? Where does all that stuff come from? Not only that, if you come from the material viewpoint, you don't know even the basics of your own materialism. You don't know where they come from. You don't know where time comes from. You don't know where charge comes from. You don't know where mass comes from. You don't know where space comes from. You don't know where spin comes from. You've got all these basic things that physics is really based on, the interrelationship of all those things. And they just are because they are. Sound like a mystic. That's what mystics say. Yeah, it just is because it is. Well, so these materialists are all mystics when it comes down to it, because they don't know any of those things. Where did that ball of plasma come from before the universe existed? It just was because it was, That's all mysticism. But when you have the MBT viewpoint from consciousness, you know exactly what time is. That's the outer time loop in a simulation. You know exactly what space is. Take any point, call that the origin, define 3 mutually orthogonal unit vectors. You've got space. You've got all space. That's it. You just made space. It's easy. It's a computation. It's information. Same with mass, you see. Gravity, part of the rule set. So you can explain why those things are that way. Why is it that we have these numbers in cosmology that the 8 decimal places have to be perfectly balanced or the whole universe would become unstable? Why is that? Well, from the MBT viewpoint, you can give a logical explanation of exactly why that has to be, why it couldn't be any other way. You see, and all these other mysteries that are paradoxes inside of science, the MBT model answers those. And not just some off-the-wall answer, but answers those with logic. The whole system is logical. You see, so it even answers most of the questions in theology as well. So that's really the big difference between the two, is that if you start with consciousness as fundamental, you can explain everything else. You can explain physics. You can explain the subjective. You can explain all those things in physics that the physicists can't explain. Those mystical physicists can't explain time and space and charge and those things. They just are, because they are. So you can explain science so much better. So you get to explain everything. And when you come up from the material viewpoint, you can't even explain your own physics. You have no idea why quantum physics works the way it works. It's just weird physics. Matter of fact, as Feynman said, it's unexplainable. It will always be unexplainable. It just is, because it is, more mysticism, physics mystics. So you can't even explain your own physics, much less all those other things. You can't explain why C is a constant. It just is, because it is. So that's the difference really between those two approaches. It's not that the idea that consciousness is computable out of neurons or microtubules is just totally impossible. It's just that it doesn't get you anywhere. You're still stuck in a materialist regime that can't answer a whole lot of things. So you know right away that it's not the answer. It's just a partial answer. It's not the answer. It breaks down and can't explain itself, can't explain quantum, can't explain, C is a constant, can't explain any of the paranormal things, can't explain creativity, can't explain really anything much except the props. Oh, look at these props. Here's a table. Want to know how much it weighs and what its volume is and what it's made of? Got that. But what's the play about? I have no idea, So it doesn't explain justice. Doesn't explain right and wrong, doesn't explain morality. From the MBT viewpoint, I can tell you what's the difference between right or wrong. Things that are right tend to lower entropy of the system in the long term. Things that are wrong tend to raise entropy in the system in the long term, period. Defines right and wrong. It's just that simple. You see? So that is the difference between those two approaches. It's not that the material approach is wrong. I mean, that's like saying it's not that Newton's mechanics were wrong. I mean, you could say that, I guess, but Newton's mechanics work wonderfully if you don't get things that are too small and you don't get things that are too fast. Newton's mechanics is good physics, and it works in the area, in just a subset of reality. It works well. Well, physics is that way. Materialism is that way. Within a subset of things, it works really well, but it's not a general understanding. It's just a science of the objective, of the material objective world, period, nothing more. Yet the world that every human lives in is so much richer and so much more meaningful than the stuff. All right, stuff is nice. I live in a house, keeps the rain off, makes it nice and cool in here when it's hot and muggy outside. I like the stuff, but it's not the centerpiece of my life. It's not what's really meaningful. It's not what's significant. All that stuff that's meaningful and significant is on the intuitive side. It's on the subjective side. That's what's significant. So that's the difference, you see. So yes, Newton's laws and Newton's physics was a good thing, and we keep them. A lot of physics is still done with Newton stuff because it's in that realm where Newton's laws work just fine. Not too small, not too fast. They work just fine. Well, that's the way it is with materialism. We're not going to throw materialism out and say, oh, all that materialism needs to, nobody needs to do that anymore. You still need that because the props are important. The props are very important, but it's not really what life is about. Life is about something more than that. So a science of the props is nice, but it's not the big picture. It's not the big Tao. It's not the theory of everything. It's the theory of the props. The play is something else altogether, you see. So if you take that route, and I was just reading a book, and in this book, the scientist basically says, all right, I'm on the trail of finding out the science of consciousness. Now, I want all the readers to know that this is serious science. So even though there is this possibility that consciousness is fundamental, I'm not going to work with that because there's really nothing I can do with that. I'm only going to work with the material side, only with the logical scientific side. Because scientists know that there's this consciousness is fundamental theory out there, and they know that they can't dismiss it, but they don't know what to do with it. They don't know how to use it. They don't know how to make it act like the stuff on the stage. They don't know how to do that. It's a different kind of animal. You see, it's a different thing. And because of that, they don't want to touch it. So this scientist, I was 14 or 15 pages into his books, and 4 times he stopped to tell the reader, what I'm going to show you is real science, which means it's just the physical viewpoint. It just comes from materialism. I'm going to show you how the physical realm can create consciousness, or might create consciousness. He doesn't claim he knows how it does, but he claims somehow it must create consciousness. Yes, I understand there is this other side that consciousness is fundamental, but I'm not even going to go there because I'm doing real science here. You see, well, that's the way scientists, that's the way physicists look at consciousness. It has to be physical because everything has to be physical because that's the belief. And they can't even begin to start with, well, let's say it's not physical. Let's see where that leads. Because if they did, they'd very quickly see that they would understand quantum physics and relativity much better, you see, but they can't go there to find that out. They would see that the consciousness is fundamental is the more general theory, the one that answers more with absolutely good logic. This is not answering more because you make stuff up. It's good logic. It's got the same quality of science as does, say, the science of evolution. You know, where we start with cells and then we got the things that lived in the water and then some of them crawled up on the land and, you know, their lungs got bigger and then they had the land things and then you had the frogs and the amphibians and then you got the mammals and, you know, we have this whole thing that the science of evolution tells us. You know, they look at the fins on a dolphin and they look at those dolphin fins and there's fingers inside. There's bones like this, like my hand in there. There's a hand and there's all the little finger bones in that thing. Well, and it's an air breather. It's got lungs and it's a mammal, you know. So how'd that get there? Well, the evolutionists, you know, tell you about how that process probably worked. And they look at the data. It's a fact-based science. Evolution is based on facts. They have lots of facts. Matter of fact, that's what Darwin was doing on his boat, the Beagle. He was going around collecting facts. And when he collected enough facts, he came up with a theory to explain those facts. And people have been collecting facts and extending that theory all along. It's a fact-based, rational, logical theory. And MBT, my big toe, works exactly the same way. It's a fact-based, logical theory, just like evolution. Now, Darwin was not a mathematician. You know, he was more of an accountant, I think, in the sense that he had lots and lots of samples and things that he had to all keep track of and see how one, you know, morphed into the other over time, and, you know, how the coloration changed depending on their environment, you know, for camouflage. And he saw all these things and put together a theory. Well, basically, that's the way MBT is. You know, you look at all the facts of consciousness. You know, remote viewing is one of the facts of consciousness. It's just something that's done. And again, if you think that is not a fact, then you're just ignorant. There's lots of studies and research and things done that is a fact. So there's all these facts of consciousness, and there's these facts of the physical world. And MBT is just a theory that explains all those facts. So it's the superset. And the material viewpoint, though it's a perfectly good viewpoint among all those things that have small uncertainty, it just works very well in a very limited space. And it cannot explain the whole thing. It only explains subpieces of it. Matter of fact, I mean, that's not like something that physicists would disagree with. They'll tell you We don't talk about consciousness. We don't talk about remote viewing. We don't talk about any of that. That's not physics. That's not science. That's subjective. And we don't do anything that's subjective. That's, what do they call it? Not phony science, but what is it? It's pseudoscience. Anything that gets into the subjective realm, that's woo-woo pseudoscience. We're scientists. We just do the props. We just do the physical stuff. That's the real science. Well, they're missing all the rest of the science that does do the intuition, that does do the remote viewing, that does do all those other things. And it does tell you why you're sad and why you're happy, how your life is, what's going on in the world from the intuitive and from the subjective side. How do we interact that way? Because that's logic too, once you understand the structure it's based on. So that's really the point in looking at these things, that yes, our biology developed through evolution in a computer. All right, that's the idea that this is a virtual reality. Right now, this is part of my idea that it's a virtual reality. Okay, so it develops, and we do have brain, and that brain does have neurons, and the neurons have synapses, and the neurons have microtubules and all sorts of other things that may or may not have, any value other than just their structural value. But mostly they probably have some value because they evolved to be that way. So there's some point in those microtubules, some point in those neurons, some point in the way all that goes together. But that point may not be for anything more than so we can run around like the other animals and jump when we need to jump and skip when we need to skip and duck when we need to duck, that we can find food and put it in our mouth. That may be about all that does. It may just make the human animal. That we make choices that go way beyond that. That we do worry about things like justice and beauty and right and wrong and morality and all those things. That we do go there may not derive from the bottoms up through microtubules. That may just come from the top down through a consciousness system that's fundamental. You see, we may have evolved that brain and all of its structure, true, but exactly what that structure does and what it buys you is not known. I mean, we don't know exactly what all the parts of our own body does. We've had parts of our body that we're not quite sure what they're good for or why we have those. So in any case, that's kind of where the science is. It's not that those guys are just wrong. It's that from their approach being based in materialism, they're limiting. They cannot answer the more important problems, which are what are in the actors' minds? What's the play about? What's the point? Is it a mystery, or is it about personality conflict? What's the play all about? What do we learn from it? They're missing all the ability to see all of that. They're just stuck in this physical, objective world where time and consciousness and free will are all illusions. And of course, you try to explain that to people, and they'll believe you if you tell them you're a physicist and it must be true, but their own experience tells them that's not true. Their own experience says, I make choices, and it's not my imagination. I'm not, imagining it. So they end up with painting themselves into corners where they say ridiculous things like there is no time, there is no free will, and there is no consciousness, when anybody's experience tells them the contrary. So they just can't deal with that world, just like Newton can't deal with things going, half the speed of light. It just can't deal with them. And it can't deal with tiny little things like electrons. It just can't deal with them. Well, materialism just can't deal with the larger reality. But consciousness can, and in the end point, actually make a more advanced physics. I and MBT Events hope you liked this video.
We now have well over 1,000 hours of free video on this user-friendly, ad-free YouTube channel. Though these videos are free to our viewers, they represent many thousands of hours in production and editing, and many thousands of dollars invested in video and audio equipment, along with the required computers and software to store and process the raw video into finished products. So far, all of this content has been funded directly out of our own pockets. Be assured, we will always continue to do what we can. It's our life, our purpose, a labor of love that we will continue to pursue as best we can. However, those pockets are not as deep as they used to be. Thus, we are now seeking to augment our resources with support from our viewers. If you find something of significant value in our videos, please consider supporting their production through our newly created Patreon account or through a one-time donation. The links are in the description below. Thank you.